For today, we're going to talk about linear regression on 12.3. So what you need before you get started is this first page already filled out. So just those first A, B, and C. Go ahead and make sure you've already done that. And then we're going to either need your scientific or your graphing calculator handy in order to learn about linear regression. So here we go. All right, so I'm just gonna jump right into this because you should already have it filled out on page 1. And it says which graphs have a positive association, which ones have a negative association, and which ones have no association. So a lot of times people get a little confused on C. There's only one that has no association. And I'll get to that in a minute, but let's do some of the more obvious graphs, or, maybe not to you, but in the past, my classes have thought they kind of stood out a little more. So scatter plot 1 and 2, those both just go straight up. Those are good positive associations. So I'll put 1 and 2 right there. 7, I didn't really do a good job drawing that line on the dots, but you can connect those dots right there. 7 has that negative association. I'm just gonna put the answers best I can. Let's see, plus sign, minus sign. Which one else stands out? Okay, 8 seems to go up pretty close to a straight line. Well, I'll fill out the top in a minute. So looking at the next, well, 6, 6 has a pretty strong one as well. 6 has that negative, that downhill slope going. And so these last 3, we just want to kind of narrow it down. What's the best representation? And keep in mind, there's only one answer for C. And so looking at these pictures, even though 3 is not as clear as 1 and 2, it's not as tight as 1 and 2, it's still going up overall. So the dots definitely have much more deviation than scatter plot 1 and 2, and even scatter plot 8, but it's still positive, still makes the most sense. And if you're not sure, draw both lines. Well, let me try them in different colors, see if it stands out more. That line, it kind of describes that upward pattern we're seeing with the dots. If I try it in green, that green line, that doesn't really fit. That doesn't really describe what's happening because these, the dots are kind of spread out the farther you get away from the line. So that one is a good, it doesn't matter what color. Okay, that one's a good positive. So it's down to 4 and 5. And so to say which one has no association, that's like saying which one looks more like you just dumped pepper on your paper. And you know what, they kind of both do, but 5 seems to start high and end low. So it kind of has that negative line. It's kind of a weak argument, but that's much, it's at least better than trying to convince me that 4 follows a pattern, because that kind of looks like all the dots are all over the place. And a positive line doesn't really describe the pattern either. You can't really tell. It almost looks the same in terms of how the dots are related to the line. So this guy is negative on number 5, and this is no association. So let me fill in that top part. We had 1, 2, 3, and 8 for the final answer. For B, let's see, we had 5, 7, 5, 6, and 7. And then for C, we had number 4. Okay, and again, there's no meaning to the color of the pens. I didn't even realize that I switched colors in the middle, so don't even worry about that. But the positives and the negatives are a review from the last section, and it was just a good place to start. And so now looking at this little thought bubble up here, this language tip, we say 2 variables are correlated if changes in the values of one variable are associated with predictable changes in the other variable. The correlation coefficient, that's what we're going to be talking about today. measures the strength of linear association. There's literally no words I can add to that sentence. Like, that is exactly every word that I want you to know. The phrase correlation coefficient, and then what does it do? It measures the strength of linear association. By the end of the video, you will have already forgotten that I told you this. So make sure you highlight it so that way at the end, when you're like, whoa, where did that come from? You can flip back and be like, oh, she did tell us that at the beginning. This is super important, the strength of linear association. And so what this is gonna denote, or the variable that's gonna go with this is R. What we're talking about today is R. In fact, look at the heading that we can see at the top, investigating the properties of R. So the correlation coefficient is R, and that is the topic of today. So far, in terms of actually doing number 1, all we've done is review. But now we're gonna get ready for number 2, and this one will be starting to talk about the relationship of R. So looking at number 2, I'm gonna do the first one, and then I want you to pause it and make sure you can do this as well. All right, so for this first one, now let's just kind of explain what's happening here. First of all, like, instructions say to use technology to find R, the correlation coefficient for each graph, and the data are given below. So technology is obviously our calculator, and I'm just gonna break this up. This right here represents graph 1. See how it has the X1 and the Y1? It's telling us the X and Y variables for graph 1. And you can see that you can just break them all up. You don't have to draw these lines in, but I want to make sure you can see so you type it in your calculator correctly. That's graph 2, that's graph 3, and so forth. So there's 8 of them. Okay, that's actually going to get in my way, so I don't really need those anymore. But as long as you can see how they're split up. Okay, so what we're going to do, oh, I'm pushing all kinds of buttons here. I am going to, well, okay. Let's look at number 1. As you're looking at this, you can see there's something on my screen. I don't know how to get rid of it. I think when I turn it off in a second, it'll go away. Okay, sorry if that's in your way. I don't know if you can see what I can see. Okay, graph 1. Type X1 and Y1 into your calculator, just like we did in 12.1. List 1 and list 2. You may need to kind of watch a video, pause it, watch a video, pause it, and so forth until you see what's going on with your calculator. You also might need to fast forward some parts because I am going to be talking about graphing and scientific calculators. So I am going to try to see myself, stop share, and start video. Ah, there I am. Okay, so this calculator first. And you go to your data. You can see that. And so we have the graph. That's all the X's and all the Y's. And these are ordered pairs. So 150 needs to be with 60. When you type it in your calculator, 150 needs to be with 60. 155 needs to be with 72. See how they're next to each other? If you type these out of order, it's going to mess it up. It needs to know the ordered pair. So you have that into your calculator. And then just like before, in fact, I'm not going to teach you anything new because we've already done all these steps. It's just we're looking at a different spot. So you're going to hit stat, where we always go in this class. Remember from chapter 12, we're in chapter 12. Remember from the last section, we're doing 2 variable statistics. And if you ever forget, 2 variables, X, Y, 1, 2 variables. Okay, 2 variable stats. This is fun. Maybe I should just be on video more because I feel like I'm just always writing and I never even get to see you guys anymore. Okay, number 2, enter. Can you see that? L1, L2. Where's your X's? Where's your Y's? X's should always be in L1. Y should always be in L2, just to make it easier on yourself. We never should have to change that. Go down to calculate. Okay, we've been here before. Go up, 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 up. And you see the A and B that we talked about before? And look what's right beneath the A and B. there's R. That third one down, it's letter F on your calculator. That tells us what R is. So what you want to do with this information, let me get there. We're going to go, so we know what R is for graph 1. So go here, and you want to write all your information on this page that you see right here, because it'll make the next part easier. So what did I say? It was 0.943. R equals, my screen's standing up, as you can probably tell by my face, so this is a little hard to write. 943. How many decimals? I don't care. 2, 3, whatever feels right. Okay, so if that's you and you are doing the graphing calculator, this one, the scientific calculator, I want you to pause and fill out all those R's and then come back. If you're using the scientific calculator, hold on, I'm about to explain it. And if you are using like a Casio or something, start Googling, because I have no clue how to use it. Okay, so going back to my big face, here we go. We have this calculator. Okay, you know how to type in a list. Nothing has changed. And for some of you, this is going to be very easy. And for others, you might have to do a little more work depending on who's used your calculator before you and if you've ever done this before. Okay, so we go to stat, we type in our list, same thing, X1 and Y1. And, oh, that's very, very unclear, but you have your paper. Again, or if you might have fast forwarded through my last calculator spiel. So if you weren't here, X 150, I can't show this to you because it's too blurry. But 150, you can kind of see it. 150 needs to go with 60. 155 needs to go with 72. These are ordered pairs. They need to go together in line. Okay, so next up, I'm going to go to stat again and calculate. And we're still talking about linear regression. So I'm still going to go to linear regression, which is number 4 on my calculator. Now, I don't know if you've noticed this, but there's 2 linear regressions. And this one, it doesn't really matter. I don't think. Let me hit it and see what happens. No, it doesn't really matter. It's just written differently, and it might confuse you because one, let me go back. Hold, please. I need to quit hitting enter so fast. Okay, stat, calculate. All right, number 4 says ax plus b, and number 8 says a plus bx. So it just has the slope in a different spot, and it's a different letter. So everything we've been talking about in class has been number 4, so just stick with number 4. Okay, number 4. So we have where are your x's, where are your y's, frequency list, calculate. If all you see on your calculator is just the linear ax plus b, then you just type in L1, comma, L2. But if your calculator looks like this, then it does that L1, L2 by itself. Okay, so look at mine. I have from before, y equals ax plus b. I have a and b, whatever. R squared, we don't use R squared. If I see R squared on your test, I'm marking you off because we're not using that for anything. And then R, right there, 0.93. 0.943. That is exactly what we want. Now, some of you only see this on your calculator and you don't have R's and you're like, oh, where's my R's? I will fix that for you right now. If you have this, if you see R on your calculator, pause it and go get all the rest of your R's for graphs 2 through 8. But stick around if you need help with your R, getting R's. Okay, so what we're gonna do, and I don't know if you want to follow along or write this down or pause it if I go too fast, but it's a couple different steps. So first thing is right above the 0, it says catalog. It's blue. So I have to hit the second button. Let me get out of here first. Okay, I'm on a blank screen and I'm gonna hit second catalog and the catalog comes up. Where is it? It's above the 0. You should be able to see it on your calculator and it's blue. Okay, I'm in the A's. I want to be in the D's. D is right here and it's green. So I hit D. No, did that not work? Oh yeah, it works. It jumps to the D's. If you just hit down, you'll get there, but you're going to get there in like 5 minutes. And I just jumped there. Okay, so I'm in the D's and I'm looking for the word diagnostics, and it is DI. So I just keep scrolling down. Ooh, how do I do this to show you? This is really hard to scroll backwards. Okay, so it says diagnostics on, diagnostic off. We want the on, and all you have to do is hit enter. Enter. It says diagnostic on. Yes, that's what I want. Done. And that's it. And you never have to do it again. And so if you go to stat, calculate, go to number 4, hit enter, boom, 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 enter, 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 enter. Then you should have the R's now on your calculator like I do. No R squareds, just R's. All right, so now no matter who you are, you should be pausing this video and getting all your R's, because you either know how to do it with your scientific calculator, you know how to do it with your graphing calculator, or you're Googling your calculator, because these are the only two that I know how to do. I'm also going to pause it because maybe then you will pause it. Hang on, let me share my screen with my lovely pause video screen. Look at this. Pause. Okay, pause the video. And we are back. So hopefully you have finished number 2. And what I did while you were gone and while I was gone was I filled in all the R's. And so double check that you have all the R's correct. Again, if you are just copying what I'm doing and you are not trying this, how am I going to know, right? Like, I'm not at your house. I'm not watching you. Oh, wait, watch this. See, now I'm watching. I can see if you're copying me or not. Okay. No, but seriously, I'll know, because on the test you won't know how to get the answer. So make sure you are putting this in your calculator and you're practicing it, because there's some mistakes people make and some error messages that pop up, and you kind of have to go through the practice of that. So that way, when it gets to the homework and stuff, you're able to do this stuff here. Okay, so we calculated, we got R. So number 3 says, compare the scatter plots and R values. Look for patterns by comparing them. How does the value of R seem to be related to the patterns? So now that you have all the R's written down, I want you to look at 3 and 4 and work through those. And when you are done with 3 and 4, come on back. And we're back. So now that you are ready to talk about 3 and 4 and you have answers written down, hint, hint, so you can compare answers, what we have here is, look at this is why I put the pluses and the minuses on the graph from before, because we want to look at our answers from 1, which is from the scatter plots, the positives and negatives, and then look at the R's. So there's a few things to notice. First of all, looking at 2 and what is that? 7 down here. R equals 1, positive 1 was with the positive graph, and look at that red line compared to the dots. The dots are pretty much exactly on that red line. In fact, if I drew it better, they'd probably be totally on the red line. Look at number 7. We said the slope was negative, and we said, and then we calculated the R equals -1. And look again at the dots. They are exactly on the red line. So there's something about the number 1. We can see from our first answers where the positive and negative came from. But now those dots being perfectly on that line talk about, have to do with that number 1. So let's get away from 1. Let's go in number order, going down. So we talked about 2. Number scatter plot 1, 0.94. That's pretty close to 1. And so the dots are not exactly a straight line, but this first graph was pretty easy for us at the beginning to say that it was positive, because even though it wasn't a straight line, the dots were really close to a straight line. All right, and then let's see, the next positive would be scatter plot 8. that R is 0.75. So the dots are starting to get farther away from the line, but then some of them are kind of close to the line. So it's not as close as number 1, or certainly not as close as scatter plot 2, but they are kind of close to the line, getting a little further. And then the last positive would be scatter plot 3. And these guys there's many dots that are pretty far away from that line. However, if I took away the green part, if I took away all of that, we could still tell that it was positive. So it wasn't super clear like number 2, but it definitely had that overall upward trend. So it definitely had that positive vibe to it. Similarly with the negatives. So again, scatter plot 7 went down in a straight line, -1. Scatter plot 6 went down, and without this line in here, we could still tell that it had that downward pattern. However, the dots were starting to get a little farther away from the line. And then scatter plot 5 has that downward pattern pretty much, but again, the dots are also not really that close together. Far away, medium far. So as the numbers are close to 1, like scatter plot 2, or -1, like scatter plot 7, the closer to 1 you get, the closer to a straight line your picture is. Now, we said number 4 had no correlation. And look at the decimal that went with it. In fact, if you went to 3 decimals, it wouldn't really even give you much information. So I went to 4. That is almost 0. That is as far away from, right in the middle of 1 and -1 as you can get would be 0. So right there at 0, that would be a very weak association. I can't, this is so close to 0 that I couldn't even tell from the picture if it was on the positive side of 0 or the negative side of 0. And then, yeah, so that's those 8 pictures. That's what is going on in number 3. So number 4, what do you think the correlation coefficient R measures? So the R is measuring, and I've said this a few times, but it's measuring how strong the linear association is. So this is the, where is it, number 4. It measures the strength of the linear association. So we talked in 12.1 about positive versus negative linear associations, and now we are talking about the strength. Where have I heard that before? Oh, look, we even highlighted it. It measures the strength of the linear association. Perfect. Highlighted in that little language tip. Coming back to B. Is there a largest possible value for R, or can it have larger and larger values without limit? And so our picture showed us that the largest is 1. Because the largest was as strong as you can get. That was a straight line. The dots made a straight line. As I drew my line through the dots, it touched every single dot. Is there a smallest possible value for R? Yes, -1. That would be the smallest because, again, that made a straight line. And there wasn't any number on that picture more strong or smaller than -1. Okay, so what I want to do is, I have a little space up here. I guess I didn't really write much for number 3, but I want to draw you a picture. Actually, I'm drawing back because the back has empty space. So we won't use all that space for B. So I'm going to draw a little picture, a number line back here. So we have, this is what we just talked about in a number line. -1, 1, 0. This right here has a strong, I'm going to run out of space, positive linear association. negative one has a strong negative linear association. 0 has a weak linear association. So 0 was the weak, that was scatter plot 4. The dots were all over the place. And 1 and negative 1 both had very strong associations. 1 was positive and 1 was negative. So this is our chart about R. Okay, so looking at this chart and number 4, which basically says that chart, but in words, I want you to look at number 5, 6, and 7 and see what you think about those 3. So go ahead. This is Fun Friday after all, so we have lots of time for you to try stuff. Go ahead and pause the video and do 5, 6, and 7. And we are back. We're looking at number 5, and you might have noticed this, but 6 and 7 both have a question that says, does this change your answer? And let me just tell you that a lot of people change their answers because they got A and B wrong on number 5. So I'm not even going to answer number 5 right now. We'll go back and make sure you have the right answer before we're done. But it kind of takes away the fun of 6 and 7 if I already tell you what the right answers are, 4 or 5. Okay, so number 6, it says the data in 2 of these scatter plots have an R value close to 0. Look over the scatter plots and decide which 2 have an R value close to 0. Don't calculate. In other words, don't put these points into your calculator. That doesn't sound like fun anyways. But it says which 2 have an R value close to 0. So if I draw a line, those dots do not make a line. Okay, those don't really make a line. So these 2 seem to be the best candidates. Let me draw a line here. Oh yeah, those dots have that nice strong pattern. Those dots on scatter plot 3 have a pretty strong correlation right there. So I'm going to throw away number 3. It's not number 3. So the answer to A is scatter plot 1 and scatter plot 2. Do both scatter plots with an R value close to 0, so looking at scatter plot 1 and 2, do they both have weak associations? And so, looking at this, that is very weak. Look how far away from the line those dots are. Ooh, that's very weak. But scatter plot 1, now if the question said, do they have weak linear associations? I would say yes, that does not make a line. But does that form a pattern? It does form a pattern. Very strongly forms a pattern. It makes a nice little rainbow right there. So do they both have a weak association? And I'm going to say no. Number 1 has a strong non-linear association. So it has a, that's kind of wiggly the way I drew it, but if you connect the dots, it makes a nice, strong rainbow shape. Very clearly makes that up and down arch rainbow shape. It's just not a straight line. So going back to what we wrote here, I wrote the word linear on all of these because R is only talking about straight lines. R is talking about linear. Where did we see that before? Right here, fuzzy, come in, highlighted. The correlation coefficient measures. There's 3 things. It's measuring the strength. I guess technically it's 2 things. And linear association, I guess, is 1 phrase. The strength, and it's measuring the strength of actually associating with a straight line. So going back to this problem, number 1 is strong. It's just not a strong straight line. Therefore, I cannot use R to describe it. Let me draw what R would look like. R, no, that doesn't anywhere near the line, anywhere near a straight line. So that's why it's considered weak. Or yeah, a weak association, but it is a strong linear association. So going back to A, can there be a strong relationship between the variables when R is close to 0? And the answer is yes. And our example would be nonlinear association. See example 6A. Are you already starting to doubt your answer for B now? Let's go check that one out. So number 7 is talking about what 5B was talking about. The data in 2 of these scatter plots have an R value close to 1, close to 0.94. Determine which 2 that is and don't calculate it. So 0.94, I know is a positive number. So looking at these pictures, I want to know which 2 go up. Positive, positive, negative. So it's not scatter plot 1, it's scatter plot 2 and 3. 0.94 means it goes up in a straight line, or it follows the pattern of a straight line going up. However, there's definitely deviation because 0.94 is not equal to 1, but it's pretty close to 1. So the dots are going to form pretty close to a straight line. All right, do both scatter plots with an R value close to 0.94 show linear associations? So let's look at these dots. Scatter plot 2, do those dots follow a straight line? No, and one way you can tell is when I drew that red line in, even though the pattern goes up like the red line does, notice all the dots are on one side. They're all here. And so this is not a linear association. Scatter plot 3, I have dots on both sides. In fact, if I drew the line a little better, I could probably get dots on the other side too. Kind of has dots bouncing back and forth. It definitely goes up in that straight line pattern compared to scatter plot 2. So for this one, do both show linear association? No. Why? I didn't look at 2. Look at 2, right? Like the second one, I think you can see from the picture that that's not a straight line. And so they both were strong. 0.94 is very strong. They both had a strong linear association, but they weren't both straight lines. So here, can variables with have a nonlinear relationship and R is close to 1? Yes. For example, what was that? 7A. We're going to look at 7A. Or I'm sorry, it was 7B. It's the middle one. It was an exponential curve. Look at that. There's our COVID-19 example of the day, because it's going up really fast. And so it's not, so nonlinear means anything that's not a straight line. So nonlinear in example 5 meant that horseshoe parabola kind of shape. Nonlinear in example 7 was that exponential growth function kind of shape. Anything that a circle is not linear. So anything that's not a straight line is not linear. Linear literally means straight line. So reminder, R, I wrote R as linear, but really we want to say R is the strength of the linear association. And so again, we have that word linear on this. The biggest it can be is 1. That's a very strong positive association, very strong positive linear association. We have -1, that is a very strong negative linear association. And then we have the right in the middle, we have our weak, which would be 0. That'd be a weak linear association. All right, so make sure you're plugging things into your calculator. Email me as soon as you start having problems with your calculator. Maybe you could take a picture of your calculator screen, or show up at my office hours any Monday from 9 to 11, and we can fix any calculator problems that you have. All right, that is all that I have for